Hello students, welcome to ePhysics. Students, here in this video we will be discussing about the main term known as acceleration. Okay, we will be discussing about acceleration. Students, in the previous video we left at velocity and there we have discussed that velocity is defined as rate of change of position. Rate of change of position means delta x divided by t, that is divided by time taken from initial position minus final position, that is known final position minus initial position, that is known as the change in position, and time taken to move from initial to the final position is known as time taken, and this ratio is known as velocity. And similarly, when we talk about acceleration, we have to understand the velocity term very clearly. Well, in velocity, students, we have discussed that velocity is a vector quantity, therefore it has magnitude as well as direction. It has magnitude as well as direction. And in velocity, we have discussed two types of it. One is uniform velocity, and the other is non-uniform velocity. Non-uniform velocity. Okay, students, now here one question rises. When we talk about uniform velocity, that is it, we have taken the example in the case of uniform velocity when the object travels in a straight line. Okay, the direction is obviously fixed over here and the magnitude is always constant at every interval of time. That is, if we see here, let us consider the magnitude is 5 meter per second. After some times the magnitude is again 5 meter per second. After sometimes it is again 5 meter per second. That is, the magnitude is also fixed over here. So here, when we say what is the change in velocity, change in velocity means what? Change in velocity, we write it as delta v is equals to velocity second minus velocity first, that is final velocity minus initial velocity. Here in this case, velocity at every interval of time is same, that is 5 minus 5 will be equal to 0. That is the change in velocity. In the case of uniform, velocity is 0. But students, when we talk about non-uniform velocity, we have seen, let us consider the object is traveling in a straight line. Okay, we are considering the straight line only because to understand acceleration, we will have to understand the velocity term very nicely, because we will be connecting the terms velocity and acceleration together. So here, let us consider the object is traveling in a straight line, and initially the velocity, let us consider it is 5 meter per second, and after some times let us consider the velocity of the object becomes 10 meter per second. And here, obviously we can see that the velocity is changing at any interval of time. So when we talk in this case, when we talk what is the change in velocity, that is final velocity minus initial velocity is equals to final velocity is 10 meter per second minus initial velocity is 5 meter per second. So here in this case, the change in velocity is 5 meter per second. The velocity changed by 5 meter per second. So here, when we talk about the change in velocity and we divide it by time, okay, here also we were talking about change in position and we divided it by time to get a new term, that is change in position divided by time. We got a new physical quantity, that is velocity. Obviously here as well, when we talk about change in velocity divided by time, we will get a new physical quantity, and that physical quantity is known as acceleration, that we will be studying in this video here. Okay, so now here students, let us understand acceleration. Now we have connected the two things, that is the velocity and the acceleration. Now how will we define acceleration? Acceleration is nothing other than the change in velocity, that is change in velocity per unit time. Per unit time. Also, student, we can define it in another way, that is rate of change of velocity. We have discussed in the previous video that whenever we talk about the rate of change means we are talking about dividing the quantity with time. Okay, so we can also write it as rate of change of velocity. Change of velocity, and this is known as acceleration. Okay, acceleration. So I think it is clear with the definition that, and also students, acceleration is denoted by A, which is equals to change in velocity divided by time taken. Clear? This is equals to divided by time taken. Change in velocity, that is final velocity, minus initial velocity divided by time taken to change the velocity from initial to the final. Let us consider that time taken is t. Also students, we can write it in a different way as well. That is, this final velocity minus initial velocity can be written as delta v divided by time taken t. Clear? So this is how we define or we write acceleration. Now when we talk about unit of it, we know the unit of velocity, that is in the numerator. The unit of velocity is meter per second divided by time, that is second, which after simplifying it becomes s to the power minus 1, which is equals to meter per second square. So the unit of acceleration is meter per second square. Students, acceleration is also a vector quantity. Okay, acceleration is also a vector quantity similar to the velocity. And vector, since it is a vector quantity, therefore it has magnitude. It has magnitude as well as direction. We will see few examples now how acceleration we can understand with the real life examples. Okay, so let's move to the examples. Now students, when we talk about acceleration, let us see how we can relate it to the real life examples. Now students, let us consider we are having any object and we allow it to free fall. Okay, free fall. Then we have studied or we must be knowing that g is equals to 9.8 meter per second square in the case of earth. Okay, this is one of the examples that you will be studying in the later chapter, that is gravitation. Okay, now let's see with a clear example of real life. Let us consider an object we have, and its initial velocity. Students, initial velocity is obviously denoted by small u. Let us consider its initial velocity is 2 meter per second. Clear? And it is moving. Let us consider the force is applied in this direction, and the object displaces in this direction, and it attains a velocity. Let us consider that velocity will be known as final velocity. And here let us consider the final velocity is 5 meter per second. Okay, and this change in velocity, let us consider students, in this change in velocity happens every any time interval, and let us consider that time interval is 3 seconds. Okay, now what is acceleration in this case? So acceleration will be equal to, that is change in velocity, it changed to 5 from 2 divided by 3. Obviously the unit is meter per second square, which is equals to 3 divided by 3 meter per second square, which is equals to 1 meter per second square. So this is the acceleration in the case of this example. Okay, now here we are seeing one thing, students, that the force is applied in this direction and the object change its velocity in the same direction in which the force is being applied. So students, in this case, we come to know that the object is moving along the direction in which the force is applied. So this type of acceleration is known as positive acceleration. Positive acceleration. Clear? So if there is positive acceleration, it means there must be the negative acceleration as well. Okay? Negative acceleration as well. Negative acceleration. So we will be discussing the negative acceleration now. So I hope the positive acceleration is clear. Positive acceleration means when the force is applied in any particular direction and the velocity of the object also changes or is along the direction of that force applied, then we say that the acceleration so produced on the object is known as positive acceleration. So let's see another example so that we can clear the negative acceleration as well. Now, let us consider, students, a object or a vehicle is moving. Let us consider a car. A car is moving with its initial velocity. Let us consider 10 meter per second. And the brakes are applied, and after some times, let us consider after 5 seconds, the car comes to rest. That is, the final velocity here becomes 0. Okay. Now, the car is moving with initial velocity 10 meter per second. After the brakes being applied, the car comes to rest, and rest means the car is not moving, obviously. Therefore, the velocity will be equal to 0. Now, here in this case, what will be the acceleration? Here the acceleration is equals to final minus initial, that is 0 minus 10 divided by 5 meter per second square is equals to minus 2 meter per second square. Here we have the negative sign. Therefore, this kind of acceleration is known as negative acceleration. Negative acceleration. Now, what is happening in this case, student? When the brakes are applied, and the force is in the opposite direction in which the object is moving. Okay. Now, the object, that is the car, is moving in this direction, and the force after the brakes being applied was in the opposite direction. That is why the acceleration so that we got is negative. And the acceleration negative is because of the change in the direction. That this negative sign shows the negative direction of the velocity or the acceleration, negative to the direction of the force applied. Therefore, this kind of velocity is known as negative acceleration. I hope the positive and negative explanation is clear with the examples that we have discussed over here. Now, students, we have discussed about uniform motion and non-uniform motion, and along with that, we have discussed about uniform velocity and non-uniform velocity. Okay. Now, here also we will be discussing about uniform acceleration and, of course, non-uniform acceleration. So let's move to that part now. Now, students, let us consider, since we are knowing that acceleration is a vector quantity, so it must be having the magnitude as well as the direction as. Okay. Now, let us consider the object moves in a straight line. Here, in this case, the direction is fixed. Of course, direction is fixed. The direction is not changing. And let us consider when the object is moving, the velocity of the object, let us consider initially V1, let us consider it is V1 is equals to 1 meter per second. And after some time of interval, let us consider that is V2 equal to 2 meter per second. And after some time, let us consider it became V3 equal to 3 meter per second. Let us consider the change in velocity that we are considering is happening in 1 second. Okay, it is also happening in 1 second. Okay, now here what is happening, students? The change in the magnitude of the velocity is happening equally. That here we are seeing the velocity is increasing by equal amount, that is plus 1 meter per second. In the first case, the plus 1 meter per second plus 1 meter per second. And here the change in this kind of velocity is because the magnitude is changing by equal amount in equal interval of time, and the direction is also fixed. Therefore, this kind of acceleration is known as uniform acceleration. Uniform acceleration. Okay. Now, here we have taken the example of the velocity increasing. We can take the opposite of it as well. Let us consider initially the velocity is 3 meter per second. After that, when let us consider the brakes are applied, the V1, let us consider V2 is equals to 2 meter per second. And after some 1 second, let us consider the velocity becomes 1 meter per second, and so on. So, okay. Now here also the velocity is changing. That is, in this case we have taken the velocity is increasing, but in this case we have seen the velocity is decreasing. So this is the also example of uniform acceleration. Okay, students. Now negative acceleration, students, somewhere it might be written as deceleration, or it might be written as retardation. Both are the same case, both are same thing. That is the negative of acceleration. Hope it is clear. Acceleration. Hope the uniform acceleration, positive acceleration, negative acceleration are clear to you. So let's move to few more examples to see whether whether the topic that we have studied is understood properly to you or not. I will ask you few questions. You will pause the video and you will try to answer it. Okay. Now let's move it. Now let us consider, students, an object. Object is moving in a circular motion. Okay. Object is moving in a circular motion, and here in every point of time, the magnitude of the velocity is constant. Let us consider it is 2 meter per second. It is again 2 meter per second. It is again 2 meter per second. Here, is the object having any kind of acceleration over here? So you can pause the video and try to answer. Hope you have answered it. Let's see it. Now, here I have asked, the object is moving in a circular motion. Object is moving in a circular motion. Now, the magnitude of the velocity is kept constant. That is 2 meter per second, 2 meter per second, 2 meter per second. But since the acceleration is a vector quantity, we are knowing that the vector quantity has magnitude as well as direction, and here in this case the magnitude is not changing but the direction is changing. Initially the direction was in this direction. Here the direction is here. Here the direction is upwards. So the direction is changing at every interval of time. Since the direction is changing, maybe that the magnitude is not changing but the direction is changing. Therefore here we have any kind of acceleration that is happening. So the object is accelerated over here. So this is one of the examples that I wanted to discuss with you. Hope the video, the topic is clear to you all. Thank you very much for watching.